See, we have already computed the average memory access time using this formula. Now the same problem can also be solved using a different formula, right? We will see that now, how we can do that. See, we will ultimately we are going to get the same answer, right? For whichever method you follow. Now we are going to see the second method. You can follow any method you like, but it is good to understand both, right? But both are very logical. Average memory access time equal to, see, one thing is for sure, whether our byte is present inside the RAM or not, we will always access the page table, right? 100% of the times we are going to access the page table once, definitely, whether the byte is present inside the RAM or whether the byte is not present inside the RAM, right? Why? Because only after going to the page table we will understand that whether our byte is present or not. So that's the reason I'm going to say that 100% of the times I am going to access 5 nanos. I am going to have 5 nanoseconds, right? In case if you want, I can cancel it 100 and 100, right? You can simply write 5 nanoseconds. Just for understanding, I have written 100 by 100. Fine. Now, after accessing the page table, we are also going to access the RAM once, irrespective of whether the byte is present inside the RAM or if the byte is not present inside the RAM. How? See, in case if the byte is not present in the RAM, what will happen is after moving the data from hard disk to RAM, we will read the data from RAM, right? So while reading the data from RAM, we will have one memory access. Now in case if the byte is present in the RAM, we will obviously be reading the data from the RAM. So effectively, whether the byte is present inside the RAM or not, we are going to read the RAM once, right? So it is going to take one memory access. So again I am writing that 100% of the times it is going to have 5 nanoseconds. Fine. See, you need to understand this, okay? This is for page table and this is for process. This is for page table and this is for process, and both are indicating RAM access time. Fine. Now 100% of the times we are going to access the page table, 100% of the times we are going to read the data from RAM. Fine. Now when will we read the data from hard disk? We will not definitely read the data from hard disk always, right? Only we will read it only if the byte is not present inside the RAM. Now when will byte be not present inside the RAM? Only during 10% of the times. 90% of the times the byte will be present inside the RAM. Now only 10% of the times the byte will not be present inside the RAM. During the time we will access the hard disk, right? We will access the hard disk. So we will always access 100% of the times we will access the RAM, fine. We will access the page table, fine. Always or 100% of the times we will read the data from RAM, fine. And only 10% of the times we should have access to the hard disk, which means we should have moved the data from hard disk to RAM, fine. So in case if we compute this, what will happen is the 100 and 100 are going to get cancelled. 100 and 100 are going to get cancelled. Just for understanding, I have written 100 by 100. Okay, you need not write this always. Fine. 5 nanoseconds plus 5 nanoseconds is 10 nanoseconds. Fine. Now these two zeros are getting cancelled, right? 50 into 10 is 500. So this is 500 nanoseconds. And this is 5 plus 5 is 10 nanoseconds. So 500 plus 10 is nothing but 510 nanoseconds. So effectively we are getting the same answer, right? So what I want you to tell you is we can either follow this formula or you can follow this formula. Both are easy, right? Both are easy and very logical. So it is good to understand both the formulas. See, one thing is, in case if you are not convinced they both are equivalent, let me prove it, okay? What I can do is I can take this expression and obtain this expression as it is. It is very easy. See this. So they have given that 90% of the times it is 5 nanoseconds plus 5 nanoseconds. So let me write that as it is. 90% of the times it is 5 nanoseconds plus 5 nanoseconds. Fine. Plus 10%. See, what I am going to do is I am going to split this, which means I am going to write this as 10% of the times it is 5 nanoseconds plus 5 nanoseconds plus 10% of the times 5000 nanoseconds plus 10% of the times 5000 nanoseconds. I have just written separately, right? 10% of the times 5 plus 5 plus 10% of the times 5000. Fine. Now what you can do is here 5 nanoseconds plus 5 nanoseconds, 5 nanoseconds plus 5 nanoseconds is common, right? So what I can do is I can take this 5 nanoseconds plus 5 nanoseconds as common. I'm taking this bracket as common, right? Now what will happen here? 90 by 100 plus 10 by 100. 90 by 100 plus 10 by 100 is nothing but 100 by 100, right? 100 by 100 is 1. So effectively this is 1. Fine. Now I have taken both this, right? I have taken this and I have taken this. Now I need to take this. So I'm going to write as it is. 10% of the times it is 5000 nanoseconds. So we effectively got this, right? See, 5 nanoseconds plus 5 nanoseconds, 5 nanoseconds plus 5 nanoseconds into 1 is nothing, right? You can simply erase it. Plus 10% of the times it is 5000 nanoseconds. Plus 10% of the times it is 5000 nanoseconds. So effectively, they both are exactly same because I have taken the statement and I have obtained this by using some simplification. Fine.